Hi, everyone. It's Alicia, and today I'm joined again by Ed of LHPU. Ed, how are you doing today?
I'm doing very well. Thanks, Alicia.
Yeah, of course. So this is the final installment of our mini-series that we've been doing that covers the Intro to Autonomous Mobility 2.0 course, specifically Module 5. And right now we're going to be diving into vehicle control. So if you haven't watched the other videos, you're definitely going to want to go back a few weeks on the blog and watch the video about path planning that we just did last week, as well as the sensor fusion video. But Ed, I'd like to turn it right over to you now to just tell us about vehicle control.
All right, thanks, Alicia. And you're right. I think this is the culmination of the previous week's work and topics. This is where we take all of those other elements, such as sensor fusion and path planning, and formulate a control system to implement that path plan. So it's very exciting. This course will provide the student with comprehensive technical fundamental knowledge with hands-on implementation experience. The course will culminate in an exciting demonstration of your skills on an autonomous shuttle car. So that's very exciting for the student. It's a lot more than just book work. We'll be actually showing your work in motion on the vehicle. So in this course, again, we're dealing with a framework for the autonomous technology, which includes measurement and data collection, sensor fusion to drive perception or interpretation of that data, the vehicle plan, the path plan, and then we're going to get into now the control, so the control of the vehicle. So we'll be developing a vehicle control that utilizes that planned trajectory as a reference to the vehicle controls. This will utilize a number of vehicle dynamic models to simulate the performance of that vehicle and of the control system in tracking the trajectory maneuver. So this is an exciting part of the course where we'll first develop the capability to demonstrate vehicle control in a simulation environment, and then finally moving to a shuttle vehicle to demonstrate that capability. Okay, in this module, we introduce you to a vehicle controls technology that will utilize a simulation environment that will allow the student the flexibility to rapidly develop the technology, the code, and the algorithms, do some experimentation with it to demonstrate the capability and demonstrate their understanding of the topic. This environment will allow us to understand system-level integration of this technology with the other modules and the hardware, and then quickly go from a lecture to hands-on development. Work will progress from the simulation environment to the full autonomous shuttle car, and this is designed to demonstrate your mastery of the subject. In the vehicle controls topic, we will put it all together to control the vehicle in a simulation environment using the previous localization and path plan work. The control system development is an extremely important topic, as I've mentioned. The objective of the controller is to enable the autonomous system to achieve the maximum vehicle dynamic performance, which will also mean the maximum amount of capability to avoid hazards. So we essentially want the vehicle to achieve its maximum control performance, which would mimic a very, very good driver who knows how to handle a car. So the objective of the section in this module is to provide the student with knowledge and experience developing feedback control systems, approaches to control the vehicle trajectory defined by the path plan. We'll start with some very basic proportional integral control algorithms and work our way up to more advanced model predictive control approaches. Model predictive control is sometimes called MPC. MPC is a strong approach for robust, high-performance control, and it's often used in real automated vehicle control applications. So this will be a very interesting topic for students to learn some of the advanced controls techniques and actually apply them to a vehicle. So again, we will work with a variety of dynamic models such as the Percepton Pod. This is the graphic showing the vehicle that will actually be the shuttle vehicle we'll be controlling in the environment. In the environment of the simulation, it'll be a model of that, a dynamic model of that. And then as we progress past the simulation phase, it'll be the actual vehicle. We'll also be using some other dynamic models from CarSim, and it has a higher fidelity model, and we'll see how that system behaves in simulation relative to some of the other simple models. So this is an exciting part of the course, and I think it'll be a culmination of the other work and very interesting to the student.
All right, Ed. Well, thank you for closing this out. This video has been the culmination of our series even. I'm just talking about Module 5. But just talking about Module 5, we've discussed the sensor fusion, path planning, and now vehicle control. So if you are just tuning into this video, like I said at the beginning, make sure that you check out those other couple blogs as well. And if you're interested in this course or any of the other courses that LHPU offers, you're going to want to get in contact with them. So you can give them a call, or you can explore a little bit more to learn more online at lhpu.com.